Hello students, I am Laxman Singh Rawat, PGT Chemistry at CIS Dasua. Students, I hope you are enjoying this method of teaching learning that CIS Dasua has come up in this hours of crisis. CIS Dasua's e-learning is helping students to study at their home so that they do not lag behind due to this lockdown. Students, I hope you have seen the previous lectures. Now, today also we'll continue with some basic concept of chemistry. Today again we will be discussing reactions in solution. In this we will be solving few numericals based on molarity and molality, and we will see some more new relations here. We'll try to describe or derive a few more relations here. Let us quickly revise what we had done on the previous day. Now let us see what molarity is. Molarity is defined as the number of moles of solute in 1 liter of solution. That is, molarity equals to number of moles of solute upon volume of solution in liters. At time the volume of solution is given in term of ml, so to convert it into liters we have to multiply it by 1000. That becomes molarity in liters now. And also at time the masses are given, amount of the substance is given, okay, then we have to find out the molarity. In that case what we have to do is, in place of mole we'll write the formula as given mass upon molar mass, okay, that will be your number of moles of solute upon volume of solution in ml. If it is in ml, then multiply it by 1000, so we get the molarity. Now what does this molarity actually means? If we dissolve 1 mole of the substance, any solute, let's say 1 mole of solute in 1 liter of solution, then we say that the solution is 1 molar. For example, if we have 1 molar NaOH, it means that we have put 1 mole NaOH in 1 liter of solution. Similarly, we have written one more example here. 0.2 molar solution means we have put 0.2 mole in 1 liter of solution. Now the concentration can be expressed in another way, which is called molality. Molality is the number of moles of solute present in 1 kg of solvent. So it is number of moles per kg of solvent. Let us suppose Wb is a gram of solute and its molar mass is Mb, and it is dissolved in Wa gram of solvent. In that case, the molality is equal to number of moles of solute. Number of moles of solute can be given as Wb given mass upon molar mass of solute upon the mass of solvent in gram into 1000. If it is given in kg, then no need to multiply by 1000. Otherwise, if it is in gram, then we need to multiply it by 1000 to convert it into kg. Or the same molality can be written as M equals to Wb upon Wa into Mb, where Wb is the weight of the solute and Mb is the molar mass of the solute, and Wa is the weight of the solvent. And if it is in gram, then we need to multiply by 1000. Remember that since in this case the mass of the solvent is involved, so the mass of solvent does not get affected by temperature, which does not happen in the case of molarity, where volume is involved. Volume gets affected by temperature, whereas the mass do not get affected by temperature. Hence, molality is independent of the temperature change. Molality does not get affected by the change of temperature. Let us solve the question. Calcium carbonate reacts with aqueous HCl to give calcium chloride and carbon dioxide. What mass of calcium carbonate is required to react completely with 25 ml of 0.75 molar HCl? Here we have to derive relationship between calcium carbonate and HCl. So first of all, we'll write the balanced equation. Calcium carbonate plus 2 HCl gives calcium chloride plus carbon dioxide plus H2O. Here we have 1 mole of calcium carbonate reacting with 2 mole of HCl. Okay, and since the solution is 0.75 molar, therefore we have mass of HCl in 1000 ml solution will be equivalent to 0.75 mole is present, so multiply that by molar mass. Okay, that much of HCl will be present in 1000 ml of solution. So mass of HCl in 1000 ml solution equal to 0.75 molar into 36.5, that is the molar mass of HCl. That gives us the mass of HCl in 1000 ml equals to 27.375 gram. So if 1000 ml of HCl solution has 27.375 gram of HCl, then 1 ml of solution should have 27.375 upon 1000 gram of HCl. So 25 ml of solution should contain 27.375 upon 1000 into 25, multiplying by 25 on the both side, we get 0.6844 gram. That means 25 ml of 0.75 molar HCl has a weight of 0.6844 gram. Now we will see how much of calcium carbonate reacts with 0.6844 gram of HCl. Again, from the balanced equation we have 2 mole of HCl reacting with calcium carbonate equals to 1 mole. Okay, 2 mole means 2 into 36.5 gram, that is equal to 71 gram. 36.5 is the molar mass of HCl. So 71 gram of HCl reacts with calcium carbonate equals to 1 mole, and the weight of 1 mole of calcium carbonate is 100 gram, that is the gram molar mass. Since 71 gram HCl reacts with calcium carbonate equal to 100 gram, therefore 1 gram of HCl will react with calcium carbonate equals to 100 upon 71 gram. Thus 0.6844 gram HCl reacts with calcium carbonate equals to 0.9639 gram of calcium carbonate. So 25 ml of 0.75 molar HCl requires 0.9639 gram of calcium carbonate to react with, and the weight of 25 ml of 0.75 molar HCl was 0.6844 gram. Now let us try to solve next numerical. If 31.6 gram of magnesium hydroxide combined with 68.0 ml of 0.725 molar HBr, then which is the limiting reagent and how many grams of magnesium bromide would be formed? In this question, we have to find out the amount of the magnesium bromide that would be formed when 31.6 gram of magnesium hydroxide reacts with 68.0 ml of 0.725 molar HBr. Moreover, in this question, they have asked which one will be the limiting reagent. So it will be the limiting reagent which will decide how much of magnesium bromide is formed. So first of all, we will find out the limiting reagent, then we will find out the magnesium bromide that will be formed. First of all, we'll write the balanced equation that we have written here. Magnesium hydroxide plus 2HBr gives MgBr2 plus 2H2O. And according to this balanced equation, we have 1 mole of magnesium hydroxide reacting with 2 mole of HBr. So from this equation we see that whatever the number of magnesium hydroxide is, the amount of HBr used is twice of it. So 1 mole of magnesium hydroxide requires 2 moles of HBr. Therefore, 31.6, this is the given mass, upon molar mass 58. Okay, this is the number of moles of magnesium hydroxide, given mass upon molar mass. So 31.6 upon 58 mole of magnesium hydroxide will require twice this much mole of HBr. So 2 into 31.6 upon 58 mole of HBr is required. So when we solve 31.6 divided by 58, we get it as equal to 0.544 mole of magnesium hydroxide. So this will require double that amount. So it will require 1.088 mole of HBr. This is the required amount of HBr. But according to the question, we have 1000 ml of HBr solution has 0.725 mole. So this is the molarity. So in 1000 ml of solution, we have 0.725 mole of HBr. Therefore, 68 ml will have 0.725 upon 1000 into 68, and that works out to 0.0493 mole of HBr. So from this answer, what we see is the amount or the mole of HBr required was 1.088 mole, but we have only 0.0493 mole of HBr. That means HBr is the limiting reagent. So it will decide how much of magnesium bromide is formed. Now, in order to find the amount of magnesium bromide, we have to find out the relationship between hydrogen bromide and magnesium bromide. Since HBr is the limiting reagent, that's why that will decide the amount of magnesium bromide which is formed. And from this balanced equation, we have 2 moles of HBr reacts to give 1 mole of magnesium bromide. Okay, and from this balanced equation, we see that the magnesium bromide is half the mole of the hydrogen bromide which has reacted. Since 2 mole of HBr gives 1 mole of magnesium bromide, therefore 1 mole of HBr will give half mole of magnesium bromide. But the number of moles of HBr that we have is 0.0493 mole, and this will form 0.0493 upon 2 mole of magnesium bromide. In term of mass, this number of moles has to be multiplied to the molar mass, which is 184, and multiplying 0.02465 with 184, we get 4.54 gram of magnesium bromide. And this is the amount of magnesium bromide which will be formed when we have 0.0493 mole of hydrogen bromide reacting. Now let us solve this numerical in which we have 250 centimeter cube of sulfuric acid solution contains 24.5 gram of sulfuric acid. The volume is given and the mass of sulfuric acid is given here. Now what we have to do is calculate molality and molarity of this solution if the density is 1.98 gram per centimeter cube or per ml. Since 1 cm cube equals to 1 ml, although we will not be requiring it, but still you need to know it. Since we know that molar mass of H2 H2SO4 is 98 gram per mole. Okay, and the molarity equals to mass is given here. Okay, we know the molar mass, volume is given, we can easily find out the molarity. Since we know that molarity equals to given mass upon molar mass upon volume of solution in ml into 1000. Okay, so this will be equal to this is basically number of moles in volume of solution in ml into 1000, so that will give us the molarity. Now given mass is your 24.5 gram. Okay, molar mass is 98 upon volume of solution in ml is 250 ml into 1000. The number of moles that comes out here is 0.25 upon 250 into 1000 forja. So molarity equals to 1 molar. This is the molarity here. Now let us find out the molality. Now we have to find out molality. Okay, the density is given and volume is given. We can easily find out the mass of the solution, and once we get the mass of the solution, we can easily find out the mass of the solvent by subtracting the mass of solute from it. This is the mass of solute which is already given here. Now second part of this one, that is molarity, we have to find out. Okay, we'll see how we can find this one out. Since we have mass of solution equals to volume into density. Volume is V into D. Volume here is 250 centimeter cube, and density is 1.98 gram per centimeter cube. Centimeter cube cancels out, so this will be left with gram, and this works out to 495.0 gram. Okay, this is the mass of solution. Now for molality we need mass of solvent. Okay, so how will we find out the mass of solvent? Since mass of solution is there, therefore mass of solvent equals to mass of solution minus mass of solute. Both are given. we'll put these values simply here. So it is 495. This is the mass of solution, and the mass of solute is 24.5. So this works out to 470.5 gram. 470.5 gram. In term of kg, this is equal to 0.4705 kg. Now we will use this in the formula of molality and get the answer. So molality, M equals to the number of moles. We have already found out the number of moles was 0.25 and the mass of solvent here is 0.4705. This is in kg, number of mole per kg of solvent. This works out to 0.53 molar. So we have found out the molarity as well as molarity in this numerical. Now today we will do relation between mole fraction and molality. Let us try to understand how do we relate mole fraction and molality. Since we know that mole fraction XA or chi A is equal to number of moles of A to the total number of moles. And similarly, if we have two components, then we will suppose the another component as chi B is equal to number of moles of B to the total number of moles. Okay. Let us suppose we have taken chi B upon chi A. This will be equal to NB upon NA plus NB divided by chi A means NA upon NA plus NB. This can be written as NB upon NA plus NB into, this will be NA plus NB upon NA. Cancels out. So overall this term becomes equals to NB upon NA. That is the number of moles of B to the number of moles of A. Thus we have mole fraction of B to the mole fraction of A equals to number of moles of B to the number of moles of A. And since we know that number of moles of B equals to given mass of B to the molar mass of B upon given mass of A to the molar mass of A. This can be rearranged. So we have chi P upon chi A equals to WB upon MB into MA upon WA. So rearranging this one, we'll bring this one here. We get X or chi B upon chi A into MA, that is molar mass of A, equals to WB upon mb. This is number of moles of B, and this is the mass of A. Okay. Since we have XA, sum of mole fraction equals to 1. Therefore, in place of this one, we can write 1 minus chi B. In place of chi A or XA, we can write this one as 1 minus chi B into molar mass of A equals to WB upon MB into WA. If B is supposed to be solute and A is supposed to be solvent, in that case, we get number of moles of the solute divided by the weight of solvent. Okay. If we multiply this one by 1000, multiplying this side also by 1000, this term becomes equal to molality. Hence, we can write molality as molality equals to mole fraction of the solute into 1000 upon 1 minus chi b into molar mass of the solvent. So if the mole fraction of the solute is given and we know the molar mass of the solvent, then from this relation we can easily find out the molality. Molality, this is the molality. Molality and mole fraction, these are the mole fraction. They are related by this relation. Molality equals to the mole fraction of B. Okay, B is here solute. Okay, into 1000. If it has to be if it is to be converted into kg, okay, if it is given in term of gram, then we have to multiply by 1000. 1 minus chi b into, this is the molar mass of the solvent. We can make use of this relation to find out the molality if the mole fraction of the solute is given. Let us solve the question based on the relation that we have derived earlier. Okay, that is the relationship between the mole fraction and the molality. The relation was given as molality equals to mole fraction of solute into 1000 upon 1 minus xb into the molar mass of the solvent. Okay, basically this one is your mole fraction of solvent. Okay, so in place of this one we can write, since chi a plus chi b equals to 1, so chi a equals to 1 minus chi b. We have used this one here. Okay, now let us solve this numerical. Mole fraction of ethanol is given, it is 0.004 here. Okay, that is xb or chi b is equal to 0.04 here. Okay, Ma, it is the molar mass of the solvent, and in this case the solvent is here water. Okay, so molar mass of water is H2O, 2 into 1 plus 16 equals to 18. Okay, so molar mass of water is 18. We will use this here. Putting all these value in the above equation, we have molality M equals to mole fraction of the solute is 0.04 into 1000 upon 1 minus 0.04 into 18. Now, when we solve this one out, we get the final answer as 2.31 molar. Okay, you can carry out the mathematical operation here to solve this out. The final result will be this one. Okay, so basically 1 minus 1.00 minus 0.046. okay, here 910 996, so it will be 0.96 here. Put this value and solve it out. Okay, now let us derive another relation in which the density is given to find out the molarity. Now here we'll make certain supposition first. Let us suppose that D is the density of solution in gram per ml, and let us suppose the solute present in it is X% by mass. Okay. Then mass of 1 liter solution equals to volume into density V into D. Volume here is 1000 ml and density is D here. So we get volume as 1000 into density. Okay, ml, gram per ml, ml cancels out, so this will be in gram. So mass here, mass of 1 liter solution is 1000 into D gram. Okay, now the mass of solute in 1 liter is mass percentage X% of this one. Okay, so X upon 100 of 1000 into D. Okay, because here the mass percentage of solute is X% by mass. This much of gram will be of the solute in 1 liter of solution. Now, since we have number of moles of solute in 1 liter equal to given mass upon molar mass. So mass of solute, okay, here in gram upon gram molar mass of solute, gram molar mass of solute. This is equal to mass of solute is, we have found out here, this is the mass of solute. So put this value here. Gram molar mass is x into 1000 into d upon 100. Okay, so we'll cancel out 1 1 1 1 2 zeros here, so cancel out this one. Okay, we'll be left with only x into d into 10. Okay, and what is the molar mass here of solute? The molar mass of the solute is here mb. Okay, now look here, number of moles of solute in 1 liter comes out to be x into d into 10 upon mb. This is the number of moles of solute in 1 liter of solution. And since we know by definition the number of moles of solute in 1 liter solution is equal to molarity. Okay, so we can write molarity as m equals to x into d into 10 upon mb, where mb is the molar mass of the solute here. So this relation gives a relationship between the density of the solution and the mass percent of the solute if it is given. So it correlates the molarity with the density of the solution and the mass percentage of solute. Now let us solve a numerical based on what we have understood now. Okay, we have to find out the molarity when density and the mass percentage is given. Here, let us read the question. Concentrated sulfuric acid has a density of 1.9 gram per ml and is 99% H2SO4 by mass. Okay, the mass percentage of H2SO4 is 99%. You have to find out, or we have to find out, the molarity. Since we know that molarity equals to x into d into 10, the mass percentage, okay, density into 10 upon the molar mass of the solute, where x is the percent by mass of solute, okay, and this is equal to 99%. D is density here, and this is equal to 1.9 gram per ml. Mb, this is molar mass of solute, and this is molar mass of solute is your sulfuric acid, and this one is your 98 gram per mole. Putting all these value in this equation, these are the values given, and we'll use this one in this equation. So we have m equals to the mass percentage 99 into density is 1.9 gram per ml into 10 upon the mb, that is the molar mass of solute, and it is equal to 98. When we solve this, we get the answer as 19.19 molar. You can solve this numerical by other method also, by simple method also. We have taken up few more examples of numericals based on molality and molarity and tried to solve it in different ways. You can try some more numericals at home. Please keep on practicing numericals at your home, and thank you.